So in this lesson, we're talking about the properties of a rectangle. Now, when you look at, we're talking about quadrilaterals. Quadrilaterals are a four-sided figure. And we talked about a parallelogram is a special parallelogram. Okay, so now when we talk about parallelograms, we can get into a range of everything. We already know that these five properties make up the parallelogram, okay? So anything that's a parallelogram has those five properties that we've already talked about. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive interior angles are supplementary, and diagonals bisect each other. That doesn't change. That stays the same. But a rectangle has two more properties. So under parallelogram, we can have a rectangle, and it fits all the parallelogram qualities, and it's quadrilateral, so it falls under this chain. And then we have two additional properties. The first one, as you can already guess, is that all angles are 90 degrees, right? They're all right angles. The next one is that the diagonals are congruent. Okay, so before we knew diagonals bisected each other, but now we know that the diagonals are congruent. So if we look at these, each quadrilateral is a rectangle, and we want to find the machine measurements. We know that PQ is 24, so SR is 24. We know that PS is 10, so I know that QR is 10. So SR is 24, and QR is 10. Now, how would I find these other measurements? Well, you know that this makes up a right triangle. And so if I'm looking for the hypotenuse, that's Pythagorean theorem. So to find SQ, it would be 10 squared plus 24 squared equals C squared. And I get 100. When I add these together, I'm going to look at my notes. 676 equals C squared. So to find C, I take the square root, and I'm going to get is 26. So the length of QSQ is 26. PR, it says diagonals are congruent, so if SQ is 26, PR is 26. And diagonals still bisect each other, so if this whole thing is 26, this is 13. So that's how we figure that out. So Pythagorean theorem is going to come back into play. All right, let's take a look at some other rectangles. No, wrong way. All right, let's get down here to the good ones. All right, so let's take a look at number 10. What kind of angles are these? I know they're alternating interior angles, parallel lines cut by transversal. These are still alternating interior angles, and I know alternating interior angles have the same measurement. So that's going to allow me to solve for x. So 7x plus 5 equals 11x minus 3. And so when I do that, I get 8 and 4x. X then equals 2. So when I plug in 2 here, 22 minus 3 is 19 degrees. 14 plus 5 is 19 degrees. And of course, that's how you check yourself. But it also, remember, they are congruent. So if I'm looking for BCE, I'm looking for this measurement right here. Well, I know rectangles have 90 degrees, so if this is 19, this one has to be 71 degrees. So the measurement of angle BCE is going to be equal to 71 degrees. Okay, let's take a look at the one below that. So, what do we know about these guys? Well, there's not a relationship here, but I do know that these guys are alternating interior. So if this is 5x minus 8, this is 5x minus 8. And what do you know about this angle measurement on a rectangle? I know together they equal 90 degrees. So I can add these together, 5x minus 8 plus x plus 20, and all that's going to equal 90 degrees. So then I get 6x plus 12 equals 90, 6x equals 78, and then x equals 13. So x equals 13, but now I got to plug in because I'm looking for x, z, y. So let's figure out what this is. 13 plus 20 is 33 degrees. So if that's 33, that makes this one 57 degrees. And I'm looking for x, z, w. So x, z, w is going to be 57 degrees. And that's how I'm looking for that. So you know how to do them algebraically. This is just an example, but if you are still struggling, come and see me.